Hey, boys and girls, yesterday we just had an introduction to absolute value, and today I wanted to show you some more about absolute value as a distance, and I'm going to show you the con practice for the absolute value as a distance. So we do have, I have a number line here. They're going to use a lot of decimals and a lot of fractions on con to confuse you, but remember they're just numbers, and you have to think about where they are and the rules that we're using to show distance. First thing I wanted to go over is why this is useful. Sometimes you can have things that are a negative value, but you just want to see how far they are from zero, or how far they are from the sea level, or whatever you might want to see. Like some geography below sea level. You want to see how far below sea level it is. It can't be negative feet, so it has to be represented in feet, even though it's 2,000 or 200 feet below sea level. You're not going to say minus 200. You might see that on a chart, but the absolute value is actually 200 feet below sea level, which technically is a positive value. So you'd have to use absolute value in some situations, and you do already. You just don't realize it. So to show you the difference here, normally if we did this kind of problem and I said, well, you have to find the distance between B and C, you would have to subtract. Well, you would say, well, I have to subtract, Mr. Perch, I have to subtract C, subtract B, because I have to subtract 2 minus 1 to equal 1. Well, I would say that was true, and normally you would say, well, 1 minus 2, I can't have it equal negative 1. That's true. But if we're talking about absolute value, and I say that the absolute value of 1 minus 2 equals negative 1, and then instead of the negative, since I have it in absolute value, I could say that it's 1, then I can subtract C from B. I can do 1 minus 2. If I think of absolute value and I use absolute value, I can use it. And before we've just said, well, you can't do that because it's a negative number. Well, now we're changing the rules a little bit because you're getting a little older and you can learn new things. So in a second, I wanted to show you how it applies to your con work today. So when you do the con work, when you're using distance to find the value of a number using absolute value, the expressions, they're going to say something about finding the expression for the distance between -4 and 1/3, -4/3 and 1/3. Well, when you do that, they're going to have multiple choice down there, and you're going to have to decide: is it none of the above? Is it one of the 2 or 3 that they're showing you? Which ones are and aren't. So I'm going to show you how you would determine that. So they're going to show you a number line, and they're going to show that they have 1/3 and -4/3 represented here. And the key here is that, just like you would in any subtraction problem, if you use the number line, you could say 1, 2, 3, 4, 5. But unfortunately, that's just not reasonable to write a number line for every single subtraction problem that you would do, or distance between. I keep saying subtraction because to show distance between something, if I said that my house was 1 mile away from yours, and your house was 2 miles away from the school, how much farther is my house from your house? You would say 1 mile away, because 2 minus 1 is 1. I'm sorry, if my house was 1 mile away from the school and your house was 2 miles away from the school, how far? What's the distance between our houses? It's 2 minus 1 is 1. So the distance here is 1/3 minus -4/3, or -4/3 minus 1/3, as long as you use the absolute value. It doesn't matter the order of the subtraction, as long as you use absolute value. So I want to show you the things that are correct and incorrect about this, and you can think how that would look right now. So I have 1, 2, 3, and 4 examples of ways to explain this to you, and I just thought I'd number them so you can see that they're separate, and that I can point out, and I can say how number 1 does it, how number 2, you know which one I'm talking about. So on number 1, it is correct because it's subtracting the 2 values that are up here, -4/3 and 1/3, and it's subtracting them, but I'm also taking the absolute value. Same thing with number 2. I'm taking the absolute value of 1/3 and -4/3 subtracted. by each other. Notice how I kept the subtraction and the negative separate from each other. Well, on number 3 and 4, they are incorrect. They look very similar. They look like they'd be correct, but you might be able to see, go ahead and pause it and try and see what's off with these two. There's something off with those two. And if you paused it and you looked and you really tried, you will see that negative 1/3 is not one of the values. It's supposed to be 1/3. So that makes this incorrect. I mean, it did subtract, sure. It did have absolute values, but it changed one of the values. And on this one, it also changed this one because it is subtracting, but it's only subtracting 4/3. And 4/3 is not, you would have to have negative 4/3. So you had to subtract negative 4/3. So I want to show you some rules that will help you get along with your con practice today. First rule, subtraction was done. Why are these right? Because subtraction was done. A difference was found. We find differences by subtracting. We want to show the distance or difference in place between two things. That shows the difference. And we use subtraction to do that. So you have to have subtraction in all of them. Each value remained the same and was not changed on these two. Each one of these have negative 4/3, which is part of the problem. And I'm going to show you that up top. Each one has negative 4/3, which is part of the problem. Each one has 1/3, which is part of the problem. And they subtract. So each value remained the same. It was subtracted. And then, in the end, there was an absolute value for the whole thing. So you have to have an absolute value also. So that will help you a lot doing your con later today. Think about that, whether these are, it doesn't matter if these are decimal numbers or whole numbers or fractions or whatever they are. If you keep these 3 rules in mind, if you look at the chart and see if they're maintaining those things, I think you'll be fine. All right. Have a great day. Bye.